So this is a video on atomic force microscopy for imaging in the attractive and the repulsive regime, calibrating the second mode of the cantilever, and also I'll show you how to do SAS imaging, attractive imaging, and repulsive imaging. The first thing I will do is calibrate the second mode and the first mode of the cantilever. The first mode I already showed in a previous video, but the reason why I'll do this is because the SAS mode is not a very aggressive mode of operation, in the sense that you can image in the SAS mode very close to the surface for a long time and the tip will not be damaged. If you image in the repulsive regime, because there is mechanical contact with the surface, you might actually destroy the tip. If you destroy the tip, the SAS imaging won't be as good, because SAS requires for high resolution a sharp tip, and we want to preserve the tip, so we'll start doing second mode SAS imaging, first and second mode. So, which implies bimodal, by the way. Anyway, so we go to the thermal. This is the thermal panel in the Cipher AFM from Asylum, and I need to make sure that I'm above the surface. This is the first curve that I just took. I'm about 50 nanometers above the surface. I'll click again just to make sure. Actually, it's very weird because the amplitude here is 10. So let me stop the system. Okay, so I'll engage again. So this is the free cantilever, and I'm engaging with 110 volts with a set point of 81. I just engage. Okay, the signal stop here in the middle. So what I can do is control, and I'll press the enter button here in the red. That means that basically this is a way to reference where the cantilever is for the system. And I'm gonna take an amplitude distance curve here with 50 nanometers of distance. That means I'm 50 nanometers away from the surface, and with a trigger of say 10 millivolts for a free amplitude of 80. So let's do that. Single force. So this is the force that the amplitude versus phase and deflection curve that we just got now, and the implication is that the cantilever should be now at this point, so quite far away from the sample, 50 nanometers, and I can go into the thermal, show operational parameters, high voltage click, high voltage relay click, LVDT click, PIS loops click, so that's all correct. So now I can do the thermal, capture thermal, and by capturing thermal in this way, by clicking these buttons, I'm actually making sure that I'm stay 50 nanometers away from the surface, because I want to be close to the surface to do the calibration. The thermal should be here. This is the first mode, it's taking already the thermal data. This is the full spectrum, and the second mode should be here. So in the previous video I calculated the nanometer to volt conversion, what was 47.82. so what I'll do is convert this for the second mode. So I'll take the calculator from Windows, and I'll just paste the amplitude nanometers and divide by 3.47, which should be the sensitivity for the second mode, and I get 13.78. So I'll write down these two numbers, 13.78 and 47.82. This is the conversion for the two modes. So I can just go ahead and stop the thermal. Now to calibrate the second mode first, what I'll do is I'll put 13.78, and all I need to do is center the second mode, initialize feed, and feed thermal data. So what I get is amplitude in volts. I put it, I get a spring constant of 126.9, so 126.9 Newton per meter. We need to keep that. The Q factor of the second mode is here, about 400, so 400, and the frequency is 45.850 kilohertz. So what I'll do is I'll control copy and control paste into the second mode. Actually, I didn't start the second mode, so I can stop, going to the main panel from Asylum Mode Master, and I can go into Bimodal Dual, okay, so all I need to do now is paste the second frequency just here. This is the second frequency. I'll keep this at 0 for now. I don't want the cantilever to have very high amplitudes when I start it. So this is the drive frequency for the first mode, which was kept, and the drive frequency for the second mode, which is exactly at resonance of the second mode also. So as we can see here, now we have the panels amplitude 1 and amplitude 2, and if I go to the thermal panel, I should see that the thermal is working correctly, but I'm not close to the surface, so that doesn't interest me now. So that's it. That's the calibration of the second mode. So the first mode was already calibrated, and now this should be the calibration of the second mode. One thing to remember, because before we stop the software, is to remind the software that the actual amplitude in volts is 48.82. This one is the amplitude in volts for the first mode, and it's very important to have that, because the Asylum will actually take this one as the real calibration. We'll have to modify this when we do the signal processing. We'll have to remember that data coming from the second mode needs to be divided by 3.47. So that's the end of the calibration of the second mode.